So, so yeah, we're going to just keep working on adding this. So yeah, this video I had to break up because of some dead time, but I'll post I'll edit it and add the first part later. Um, so yeah, basically we had just figured out how to add the scan data, which is basically this soil moisture network data. Because yeah, the soil moisture is useful. We kind of had designed this function to get all the values of how close it is for different gauges. So yeah, that does seem to kind of work in by then sorting it. So we can see for this, I think this is the gauge in Maine. I think this is the big boy. It's the St. John River, so we can see this does seem to make kind of intuitive sense in that the closest places of soil moisture is this Hubbard Brook in New Hampshire. Um, which yeah, I mean honestly isn't great. It looks like it's 245 miles away, which is quite a bit of distance. Um, so yeah, the PEMI. So there is going to be some difference, but we do now have that kind of data. So yeah, let's see. That there. Um, so so yeah, the function does kind of work well. What we might do is then um I don't know how much it makes sense to put this. Yeah, I guess we can put this thing in the metadata, but um I don't know if there's an ID, a good ID. So one of the things we might do too is add like an ID to the scan data and then throw it in its own BigQuery table. And then people could then probably also just query stuff on their own too. Um, that's something we might do. But yeah, it's definitely going to be lacking, I think, for certain areas. Um, but yeah, that's probably the best we can do for now. Because yeah, I don't want to also spend forever just looking for more sources of soil moisture data. So so yeah, we will put the closest thing in, but we'll also I think write this to a table itself, and then people can query and see. And hopefully over time we can find more soil moisture sites that aren't just from scan. Um, Let me see actually. SMAP. So so yeah, I think scan though is the only one that records, I think, the data on basically what amounts to like an hourly basis. Mm, report. Let's try that. So this is the period of record. Um, yeah, this isn't exactly related to adding the data, but to the metadata, but this is the URL generation. So this is the pure. So yeah, this is, well, no, this is daily. So the scan data seems to be daily. Um, for a lot of missing data. Well, that's probably because it's in Alaska. I'm gonna throw that query though. So that's actually a period of record query. So it's not a date time query. But in any case, let's see. Yeah, I think I might write this table. Daily soil. Yeah, the weird thing too about some of this data from different from government agencies is like there'll be one network and then there'll be another network, but because it's with a different agency or whatever, like you you have to go to a different site for the other network. So, and if you didn't look it up, you might not even know the other network exists or something. Um, um, okay, so yeah, I mean, I don't know the exact details of this. So these are soil moisture maps. For now, I guess we can soilmoisture.com. So yeah, I have looked at here before. But yeah, it's just obviously I'm kind of some of this I already knew, but yeah, like honestly like 245 miles away probably isn't a great distance. I wonder why there's almost no soil moisture in Maine. Like I guess New England as a whole is surprisingly sparse. I guess no one like see the part of the challenge too with this is like um there are a bunch of different networks, but they're and then like you have to design if you're trying to design a data set, you have to like design like scrapers for each of these different networks, even though like they're kind of a pain. Like I don't know, like for instance with this thing, like just looking at Nebraska, there's like apparently a Nebraska Mesonet or something. So I don't know if that's probably not shown in the scan data set. That's something that you'd have to probably scrape from Nebraska. Um, Nebraska. or like New York. So yeah, yeah, and we don't know exactly what each site is too. Okay, I mean this is kind of going out of the so oh, so this actually has 5-minute granularity apparently, which is interesting. So if we scrape this from like, I don't know, 2016 till now. But I mean, I don't even know if these have like moisture, for instance. Oh, it does have moisture here. Okay, so I mean, that might be something to look into in a later version. But yeah, I just kind of got sidetracked on that because what I think you could do is you could create like a general table called maybe soil moisture. And right now just populate it with the scan data. Basically this, yeah, may even have something just like this, the network. So then as we add more networks, we get more data. And then add that on. So yeah, I think that might be worthwhile. So for that, we'd actually probably go back to our infra repro. We'd look at creating a new table. What do you mean? Can't you just always... It's obviously Visual Studio Code I want you to open that crap with. So yeah, so I think we could create just basically for now a table. That. So this is our metadata table. So I mean that note, I don't know how worth it is just filling in with the closest scan site at the moment. Because particularly like for some places like that might not be the best one overall to pull data from, but what might actually make more sense would be to maybe put that to JSON. Oops. So okay, scan df. Yeah, the other problem is these don't have kind of a unique ID. I mean, I'd like to... I don't know if this thing in the parentheses is a unique ID. Because then the other thing to do might be just to store these in JSON, since BigQuery can take JSON, and then people could see for sure how close they are. Because the thing is that what you don't probably want is like to just say store like this thing as the closest one, and then someone like automatically assumes, wow, that must be a good site, and just automatically throws data into the model from that and expects good results. Because like if it's that many miles away, it's probably not going to be... It might actually, for this river, it might actually be better off not to like have the scan data, because it might be hurting it if it's like scan data all the way from New Hampshire. So, but what we could do maybe is just actually add. Actually, for now, I think what I might do is add 2 columns. Um, we could add 2 things to the JSON. Like, one could be this closest scan site, and then the other one could be the like distance. So let's see. So if we're gonna do that, we could do metadata file. So closest scan ID equals. So this is what we'll do, I think, initially. Scan df, then iloc 0. Or maybe not that. Get first row. Okay, head. So we can just get head. Sync values. And then. But yeah, we don't really have a identifier either, which is kind of a problem. So what we might do, scan df. So we're gonna make an ID column. So I think we can use these numbers as so lambda x dot split. Maybe we could split on that. Or alternatively, we could use regex. No, we want 1. I think that would work. String index out of range. Split. Do that. Though I don't know, because that might create something weird. Oops. What? Okay. No, I mean, if I have a string like this, and I do dot, I have like a string like this, and I do dot split, and I do yeah, I want this shit. Probably easier to use regex. let's see if this works. Because yeah, this will give it kind of, I think these can then become the ID. So, where the heck is this shit? Did I get rid of that? No, oops. Wait, no. Oh, that was there, I guess. What? Where did my thing go? Okay, yeah, here it is. So, X. Will this actually work? See. Oh, there it did. It looks like it actually worked. Yeah. Okay, so that seemed to work. So, yeah, that's nice. So now we have the scan ID. So, okay, so that's the scan ID. And what we can do is then equals scan ID. See, oh shit. Scan ID 115.206. Wait, what? Wait, why are there two things there? I don't know why that is. Let's see. Now I need to do this. So it should be 2069. Or wait, what did I call that? Oh, closest scan ID. Wait, where's the 115 coming from? Oh, probably this thing. So it'd have to be dot values, I think. Maybe that's it. So I think that works. What we can do too, is add a tools. Anyone with link. You can add this to the issue. We'll just call it like a working notebook. So I mean that code basically accomplishes kind of what this task wants. I mean, according to how we define the task. But of course, as we saw within it, it doesn't really. I don't know how useful it is for actually solving the problem because you could get a site that's really far away, and now the question is like, um, does it really make sense to like throw all these into some table when the site might be really far away, um, and not. And I almost think it would be better not to have this as a field, initially at least, but then have like another table people can join to and try to find the closest for that place, and then that table obviously could be dynamically kind of updated with other networks, I guess. So that's something. And then I'm also gonna check something like ASOS. Let me. So yeah, there are these different moisture networks, and I don't know how. So that's Snowtel. I guess they're calling Snowtel a moisture network too. What's iron? So this is another API that might be coming up. Um, so that's not yet active as an API really. So I don't know how much of these like local state ones might be worth pursuing. And what they all have, because each seems to be somewhat different. These like Mesonet, whatever. So, and some of these have persip, which kind of over agriculture. About. Oh, they put that. Yeah, of course, Texas would have something behind a paid service. Neon, Scan. Yeah, because, like, of the percentage, like, these are, like, Scan looks actually only to be a small percent of these. Like, a lot of states seem to have their own shit, and then, well, number of states. I mean, of course, and yeah, North Carolina has Econet, which I've worked with before. What's Oklahoma? But yeah, something to do would be then to see. But yeah, I don't want to spend years just getting soil moisture data. Is this moisture? So some of these do have soil moisture, actually. Soil moisture different stations. Does ASOS have soil moisture? So yeah, I don't know if I don't think ASOS had soil moisture, because if it did, I would have just used that. Yeah, no, it doesn't. It has like things like air temperature, precipitation, but not the soil moisture. So yeah, ASOS doesn't measure that. But some of these other state networks apparently do, so okay, well, I'm not gonna get into that now. There's just too much. But what we can do, as I said, is like create a table and then add to it probably. So okay, we won't work on that now. So we did have the scan file there. So this notebook's obviously still messy. So, I mean, that does return the closest station in the file. Maybe what we could do is just actually have it as kind of a JSON thing where it's like, the closest and the distance, I guess. Scan ID. Or yeah, I guess we could do it at a cutoff too. Wait, why does that still look like it's putting an array in? I don't want an array. Dot values. I just want the raw value. Okay, there it goes. So what we can do is maybe yeah, so actually let's do it this way. We can store, or wait, we might not have included that in the original schema, but it could still work. We could just do, I don't know, the Terraform equivalent of a migration. And what we could do is, God, no, I don't want to use Xcode on that. Schema ASOS list full. Closest scan site. So this is supposed to be a string, actually, which probably is not a great idea. So we could actually make this JSON and then just store that kind of and then maybe store, I don't know, maybe the top 2 as JSON, or the top 2 are free closest as JSON. I think that might work. So we'll call it closest scan list. And a good thing is we can just I think Terraform should handle that. It should actually Terraform plan. Oh yeah. So this, oh yeah, we had copied this before. Okay, I'm not gonna do this right now because I'd have to probably look over creating more of the schema. But one of the things to do would also be creating kind of like just a table for that scan data. The scan and other network data as we add it to come in and stuff. So, but we could do Terraform. Let's do Terraform init, Terraform plan, and so it looks like it's going, well, it says it's going to create this table, but in reality it should overwrite it. I don't know what it will do. We don't have anything in the table now, so it doesn't really matter. But in the future we might just want it to add the column. So it looks like it did create the table. Which really means it just should have changed the field. I think we had inserted one random thing there, so I'm not sure if it just overrode it or... Details. Oh wait, shit. So this is what happened last time, is actually it had an expiration on the table. Terraform change GCP. So yeah, I want this change because we don't want things to ever expire. But how do I do never? Okay, so it's I think you can set it to never automatically. So we want, or maybe just not include that. Then it should set to never, I think. Because once we add this, we don't want it expiring, so. Okay, yeah, so it looks like that should fix it. So yeah, it's still complaining about the bucket, but I think that fixed shit. Okay, so So yeah, now basically I think we can just save that stuff to JSON and we'll expect some JSON. So we're just gonna say I think maybe the top 3 closest sites at this point to JSON. Then later maybe we can overwrite them or something like that. Okay, so basically instead what we're going to do, scan df head 1 through head free. I think we can just do 2 to JSON. Maybe that will work. So let's see what this says. Okay, did I rerun that? What? Then why is it still saying closest? If we're just mapping that to JSON. That doesn't make sense. Okay, so if we're mapping that to wait, why is it? Oh, there it goes. So site name. That's not really how I wanted it to be in JSON though. I would have preferred the site ID and then the distance each map to each other. So actually really what I'd want is so that's so I think for I in range. So for I in range, basically, So basically, okay, so ID column. Group by. Yeah, I don't like all those for loops. Yeah. Yeah, I mean, that's what I was thinking, but, okay, yeah, so, yeah, I don't really want all this stuff, first of all, and then, okay, let me go, let's grab the scan again, and then we could go to JSON. Yeah, so it's doing, oh, this would be the time for loads. Scan one. Scan one. And we said scan ID. Okay, so yeah, so Yeah, I guess we could just do that and then a for loop. Scan one dot. So in this case, so yeah, we'll have to describe that dynamically too, but so yeah, I don't know if this will work, but yeah, the idea is just to create a dict of the scan ID and the distance of each. Is basically the idea. F. I don't know if there's a better way to do this though. So no, then this would just be if this actually works. Ooh, maybe it did. Okay, yeah, so that seemed to actually work. Yeah, I mean, so the idea is just to create a mapping, and then basically we would just dump this mapping into the scan IDs thing, I think, so. Actually, I mean, when we do this, maybe... Actually, I might do... Scan DF. Yeah, I mean, I might just do this under distance. Then each time it would get overran anyways. But by then it would have been saved in the file. So I'm going to do that. And then... scan df dot to JSON. Actually, if I set it to a column, scan set index. Okay, cool. Yeah, then we wouldn't need to do that, I don't think. Instead, we could just do JSON.loads and then distance, I think would work. So let's see. Okay. Meta file. Okay. Oh wait, no. Oh, okay, that might be because it might not have been the one that was passed. In okay, so yeah, I think that works. And then yeah. No, then that's all of them, I guess. We probably don't want all of them. Okay, because we just want a shorter one, so it's not like ridiculously huge. Okay, so that's basically what we want. And then, okay, so then that's basically what we can do. And now we just have to write a loop essentially to do all this shit and then upload the files. Which I'm probably not going to do right now because the stream's already been going on a while. But basically, in this issue, we would have had so we've done this. We still need to run this. I don't know if we need code to test explicitly. This wouldn't be added as a unit test probably, but we should just like probably do several more like checks on different gauges before running this end to end. But we have this base code now, and then we have yeah, so we did that. So yeah, we just need to maybe do a couple more checks and then write, this loop to essentially loop through every file in this directory, make these run this function essentially, and then upload the result file. Though I guess, that shouldn't really take that long, but it might. So for that, we would do import OS. Move over dir Python. Yeah, so OS. So and then add scan station. Path.join. Yeah, the meta file. So add scan station meta. Okay, so this should run. So we just need to, oh yeah, JSON.dumps. Yeah, we can run make dir. No. Scan 112. Actually, let's see if that works. Okay, so it's running, I think. You can just pull up a couple random of these files, and really we'll just check to see if the things are at the end, and then if they make sense. God, I want to always open that with Visual Studio. So closest scan. So this says the closest scan is 2069, and it's about, I think it's saying it's 86 kilometers away. So let's just see if that makes sense. Actually, we can go back here. 2069. So that's Hubbard, Brook, and NH. And this site was, what was it? It was 11. Moverbrook at Dedham, Mass. So Moverbrook at Dedham, Mass. It says it was about 86 kilometers from the scan site. 40 miles. That's, so let's just check. So the scan site would have to be in like southern New Hampshire or something then. Or is that miles or kilometers? I don't know if that would be 40 miles. I'd think that would be more than 40 miles. Where was the site? It was like, it was a little south of Boston, right? So south of Newton. It's a little south of Newton. That's about 116 miles. Well, this is a very inexact thing, but I think it would be more than, definitely more than 40 kilometers. Sure, that's right. Okay, wait, I'm gonna double check that. this thing go? So, okay, yeah, that's the one we just downloaded, I think. So, okay, so it was USGS. Loverbrook at Dedham, MA. I wouldn't think. Yeah, I mean, I don't know why it's saying that. Yeah, I wouldn't think it would say that. Wait, did I really say 80? I think that's what it said, though. $20.69. So it did say 2069 was 86. So, I mean, maybe miles, but not kilometers, I wouldn't think. And the function I saw it did it in kilometers. Use 39.56 for miles. Wait, where's Dedham? Or wait, where's the gauge? That might... I don't know why it's saying that. Yeah, I don't know. Kilometers. Shit. Yeah, I have no idea what's wrong, if it is wrong. So we will see. That says it should be 194 kilometers. What's 86? Shit. Okay, wait, I'm gonna stop that for a sec. Okay, let me try this thing again. I can look at both of the things. What was it called? It was 1004. So we'll just try this from here. See like what was going wrong. $86. Wait, it might be the fact that one is negative. Scan df equals scan df dot apply distance. I don't know, is the haver sign wrong or something? Because I don't know. I'm just gonna say for lat longe 1. I'm just gonna copy. Or no, that's my to-do shit. Latitude. So if we copy these, I don't know. So that does return 80.6. Let's see. Shit, is the haver sign thing off? 82. Maybe it has something to do with the negatives. I don't know, maybe something to do with the negatives. No. See, I thought that's exactly what it was. Oh wait, I think, oh shit. Might have been putting the coordinates in the wrong fucking order. Fuck. That nearly fucked everything. 193. 190. Yep, that looks about right. Yeah, that matches then. And that makes more sense with the actual map then, too. So these things have to be... So, fuck, that was a stupid mistake. So... yeah, it looks like I was putting everything in the wrong order. So... So, yeah, basically, I think... Okay. Wait, so now the closest one to Mount Mansfield would actually be... would it actually be all the way in Mount Mansfield? For St. John? Okay, now I'm gonna check this again. Well, St. John River is like way up here. So... So yeah, I mean, it is conceivable that that would be closer. Though yeah, it looks like just barely still. And then yeah, this makes sense because then Hawaii, shit in Hawaii would obviously be the furthest away. Okay, so that kind of makes sense now. We'll rewrite. So now do have to rerun everything. Likewise, we'll do a couple more validation checks on all that shit. But yeah, I guess that shows the importance of testing. Okay, let's see. So let's try this again on another random one. So I think these should have been overrun by now, pretty far down. So let's check this one. I have no idea where this thing is, but we may try something here. Okay, let's try this one. So this is a river in New York. Dahlia River at Rockdale, New York. And it's saying that the closest thing is 2011. Which is in Ontario. But wait, which is actually in New York, so let's see where this is. So that's where it is. It's saying the closest thing is this. Geneva 2011. Okay, I mean that seems plausible. How many miles was it saying? Let's see. It was 144. So I forget, can you just paste coordinates? I remember it's kind of a weird thing. So that is right near Geneva. And yeah, I mean, knowing New York State, that probably could be like 144 miles. Because I think, let's see. No, oh shit, that was from the old one. Measure distance, and then the river. We were done with that river. Let's just check. That looks like about 89 miles. So in kilometers. Yeah, right around that. That looks right. So let's pick another one. So it finished, so that basically means now everything should probably be overridden. So let's just try this one. So this is in Mississippi. MS, yeah, MS is Mississippi. So closest scan is 2064. Town Creek, Littleton, Mississippi. So that is in Mississippi. And it's only 67 kilometers. So yeah, I'm assuming this should be fine. Be my guess. What? That's Antarctica. Or what? Whoa, I think that was Antarctica. Though that I'm pretty sure was from me pasting that wrong. Antarctica. Where did my core sheet go? No. Oh yeah, it should still be this way. Yeah, it's still that way first. Yeah, that's why. That good old good Mississippi. So, yeah, that looks about right. And then let's clear the distance. Measure distance. And then the gauge site was see, this is a situation where it might have been better to actually just write some automated tests. So yeah, that's about 41 miles. And how many kilometers? 67. Yeah, that seems right. Okay, let's try one we know, which is like Boulder Creek. So Boulder Creek should be in here somewhere. Because I've just been using that a lot, so it's like, might as well throw in Boulder Creek and see what's in here. And it should be in here. So this is actually almost more of a test that this stupid thing went through everything. Where is it? Come on, where'd my thing go? No. So I'll actually try this one. Oh, oops. I'm getting sloppy. Come on, thing. Can't you maintain a connection? So it actually did get it. So it said the closest scan site was 80 kilometers. We'll just see if this is in the ballpark. I'm not going to look it up again. So is in Weld County, which isn't that far from Boulder. So yeah, it looks like that was right. So I think we can say this thing was fairly well tested. We might try one more just to see if it's in there. So this is the Kern. It's in California. And try that. And okay, so yeah, it looks like it actually went through all the shit. So now we just have to copy it back to the main site. So let's do this. GSUtil. So yeah, it did seem to run through all this stuff. So I think we just need to copy it back now, and then we should be good. That one wasn't in for some reason. Maybe that was too many. Yeah, it might be missing some California sites. I don't know, so that was right. I thought maybe when we did the initial poll, it didn't download everything. So it hasn't been in the meta, some of these, for a while. I don't know. It might just be some random ones aren't popping up. I think most of them are in here. We might be missing some of the gauges, I feel like, actually, in the far west, like in Washington and California. So yeah, some of these might be missing. Okay. Yeah, so that's something to maybe investigate later why some of those were missing. But yeah, if we go to the end, I wonder if it would show. So it looks like 3,000, 4,000, 5,000. So it says there's 5,432. And what are these? This one's in Bismarck. Okay, so I mean they had some from Utah, but I don't know. Why some are missing. In any case, I think this code is correct. There just seems to be some gauges missing overall, particularly from the west. So, I mean, I'm gonna go ahead and probably check this off as kind of done. And yeah, I don't know if stuff's missing for Nevada too and stuff. But yeah, we really should get these other states in if they are missing, and then we can like this. I doubt this is in there. Oh, it is actually. So then this should be in there. Okay, it was. Okay, anyways, we'll wrap that up for now, and then we should be back sometime in the next couple of days.